When we're graphing multiple variations, I've kind of outlined some steps that we can follow to do this. So the first thing we probably want to do is figure out the vertical center. So the middle line, the horizontal line that represents the center of the graph. We want to then determine the phase shift to figure out where we start, calculate the period, and then find the end position based on the period, divide it into the 4 quadrants. We can do that by half and half. And then we can use the amplitude to determine the max, the middle, and the bottoms, or the crests and troughs. So here's an example here where we have a sine graph. There is a horizontal compression involved here. There's a horizontal shift. There's horizontal shift here. And then there's also a vertical shift here. Okay, so we want to identify those parts. So we want to know the amplitude. The amplitude in this case is 1. Okay, the vertical shift is +1. We have our horizontal shift. Okay, it's in factored form. Now it's important that we understand the difference between the factored form and the non-factored form. In the factored form, we can find the horizontal shift easier. So that's the form that we're gonna try to get. We can accommodate non-factored forms because we can undo the x transformations and do it all backwards, but it's much easier to have the factored form because in that case we have the compression expansion first and shift last, which then with these trig functions allow us to identify the horizontal shift. In this case, the horizontal shift is plus pi over 2. Okay, so I'm just going to highlight that. And then that's our vertical shift. And lastly, our period. The period in this case is based on the b value of 2. So it's going to be 2 pi, our horizontal compression of 2. So the period is pi. So we want to first of all get the vertical shift. It's +1. And when we draw in our vertical shift, we want to just be aware of the amplitude because we're going to have to fit in the amplitude relative to that vertical shift. So that's going to be y equals +1. There's a vertical shift. Our horizontal shift is plus pi over 2. When we draw our horizontal shift in, so I'm going to maybe draw in my y-axis here. When I draw in my horizontal shift, I have to space it so that I can fit in the full period. So if I shift it pi over 2, I just have to make sure that I can fit my period of pi into this graph. So there's my starting point of pi over 2. And I have to go pi to the right because that's my period. So that's going to be half a pi. 1 full pi gets me to 3 pi over 2. So there it is. There's my ending position. Okay, so I have my start, I have my end, I have my middle. I'm going to divide it into the quadrants, so I'm going to find halfway. Okay, and then halfway again. And then halfway again. Okay, so those are my parts. I'm going to calculate the quadrants. So halfway between pi and pi over 2 and pi. So I do half pi plus 1 pi is 3 over 2 pi. Divide by 2 gives me 3 pi over 4. That's halfway between 3/4 is halfway between 1/2 and 1. I add these together, I end up with 5 pi over 2. Divide by 2, I get 5 pi over 4. So now I've got my quadrants. Now I'm going to graph it. It's a sine graph, so it starts in the middle. I know it goes up 1. Okay, so that's going to be a value of 2, 1, and 0. It's going to go back down to the middle, down 1 from the middle, and back up to the middle. I've drawn in my reference points. I can draw my quadrants, quadrant 1, 2, 3, 4. And I should work out the coordinates. Here's 3 pi over 4 and 2. My minimum point here is going to be at 5 pi over 4 and 0. So when we're doing this, it really is important for us to factor out the b term. And that allows us to isolate the true shift of p. Allows us to figure out the actual phase shift where we start from. So we will always want to work with the factored form. Okay, so I'm going to make a note of that. Use factored form. Okay, these are much easier when we do it with factored form.